In this video, I'll show you how to install the Kasm integration within Rancher using the official Kasm Helm chart. This is going to be a simple walkthrough using a test Rancher cluster. And by the end of this video, we'll have the Kasm control plane up and running, and I'll also showcase launching a container-based session on my Kasm deployment. So this right here is my test Rancher cluster. If I go to Apps, Charts, and then search for Kasm, you'll notice that there are two charts available, Kasm and Kasm Demo. For any kind of evaluation or real usage, we strongly recommend using the Kasm chart. The Kasm Demo chart is an older version and it's not ideal for production style workloads. So for this video, we'll be using the standard Kasm chart. If I click on the Kasm chart, you'll see there's documentation available, including installation instructions. One important thing to call out here is that this chart expects you to provide an SSL certificate for ingress. If you already have a certificate, you can use that. Otherwise, you can generate a self-signed certificate, which is exactly what I'll do in this demo. You can find the command to generate the OpenSSL certificate on our Kasm Helm chart GitHub repo. The link will be in the description below. I already have a VM available where I can generate certificates using OpenSSL. This could be done on your local machine or any system with OpenSSL installed. I'll execute this OpenSSL command, and this will produce two files, a TLS certificate and its corresponding private key. Now that we have the certificate, let's go back to Rancher. The first thing we need to do is create a namespace, because we'll be storing the certificate as a Kubernetes secret, which requires a namespace. For this demo, I'll create a new namespace called Kasm. Once the namespace is created, I'll navigate to Storage, Secrets, and create a new TLS certificate secret. I'll choose the Kasm namespace and name it something like Kasm SSL, and then paste in the contents of the private key as well as the certificate. If you already have a certificate signed by a trusted CA, you can simply paste the private key and public certificate here as well. Now that the secret is created, I'll copy the name of the secret since we'll need it in the Helm chart configuration. Now I'll go back to Apps, Charts, search for Kasm again, and then click Install. I'll make sure I'm installing it into the Kasm namespace that I just created. There are a few fields we need to fill out here. First is the public address. This should be the host name where your Kasm control plane will be accessible. Next is the certificate secret name, which is the TLS secret we just created. I'll paste that in here. I'll also enable ingress. Since I'm using ingress, I'll keep the service type as cluster IP. If you prefer to use a load balancer instead, you can simply disable egress and configure it that way. These are the minimum settings required to get the chart up and running. That said, there are many additional configuration options available. You can browse and customize them directly from the Edit YAML tab. All of these options are documented in our Kasm Helm chart GitHub repo. If you open the values.yaml file on the GitHub repo, you'll find detailed explanations for each setting along with examples. With that done, I'll go ahead and click Install. The deployment will now start, and this may take a few minutes. You can open a shell to monitor the pod status by running this command. As you can see, most of the pods are initially in an init state. This is expected, so we'll just give it a moment. Alright, as you can see, now all the pods are running. If I navigate to my Kasm URL, you'll notice the browser shows a security warning. That's because we're using a self-signed certificate. If you were using a properly signed certificate, you wouldn't see this warning. Now let's grab the admin credentials. This is pretty straightforward. If I go to the installed apps on Rancher, go to Kasm, and then open the Kasm release notes, you'll see several commands listed for retrieving different values, including the credentials. As you can see, here is a command to retrieve the admin password. I'll copy and paste this command to the shell, and this will display my Kasm admin password. The admin username is already provided and is constant, so I'll just paste the username and password and then log in. And as you can see, the Kasm control plane is now up and running. At this point, the Kasm control plane is up and running, but we can't launch any sessions yet because we don't have any resources connected. From here, you have a few different paths that you can take, depending on how you want users to access sessions in Kasm. You can connect Kasm to existing infrastructure, such as machines that are already running SSH, VNC, RDP, or Kasm VNC, and start brokering sessions to those systems right away from Kasm. You can also deploy Kasm Agents on Linux systems to enable container-based sessions. If you want to deliver Windows desktops or applications, you can also add Windows VMs or servers and use them to host Windows-based sessions through Kasm. Both Kasm Agents and Windows servers can be auto-scaled. Autoscaling allows Kasm to automatically provision and deprovision resources based on real-time user demand, so you don't have to keep systems running all the time. This works across multiple cloud providers, as well as on-prem environments like Harvester and Proxmox. Let's start by seeing how to connect an existing Windows VM to Kasm so that Kasm can deliver Windows sessions to users. In this lab, I already have a standalone Windows VM running in Harvester. This VM is not created by Kasm. It's just a regular Windows virtual machine that already exists on my Harvester environment. This is a very common scenario, especially for users who are looking to deliver traditional Windows VDI style workloads. So first, I'll go ahead and power on the Windows VM on Harvester. Once it's up and running, I'll connect to it via RDP and install the Kasm desktop service using the steps from our documentation. The installation requires three values. First is the hostname or IP address of your Kasm API. Second is the port the Kasm API is running on, which is 443 by default. And third is the registration token. To get the registration token, I'll switch back to the Kasm control plane and navigate to Infrastructure, Servers, and then click Add Server. Over here, I'll fill in some basic details like the friendly name for my server, deployment zone, and I'll also enable Kasm desktop service installed. Next, I'll set the connection type to RDP, enter the IP address of my Windows VM, and set the connection port to 3389. Kasm supports multiple credential types, but for this demo, I'll use static credentials and enter my Windows username and password. If you want to learn more about the different authentication options that you have, check out the dedicated video on our channel. Once I click Create, Kasm generates a registration token for this server. I'll copy this token and paste it into the Kasm desktop service installer and click OK. This allows the Windows VM to securely register back to the Kasm deployment and be managed as a server resource on Kasm. Once the installation completes, the Windows VM checks in and becomes visible inside the Kasm admin interface. Now that the VM is registered as a server, I can create a server-based workspace in Kasm. To do that, I'll go to Workspaces and click Add Workspace. I'll then configure this workspace to use the Windows server that we just added. With that done, I can now launch Windows sessions using this workspace. I can either use the web native client or use an RDP client. I'll select web native for this demo. And as you can see, I'm now connected directly into my Windows VM through Kasm using just the browser without needing a separate RDP client because I selected the web native client. Now that we have seen how easy it is to connect Kasm to an existing Windows VM for traditional VDI style sessions, let's move on to container-based sessions, which is where Kasm Agents come into play. Over here in Harvester, I've already created a virtual machine called Rancher Test Kasm Agent. This is just a vanilla Ubuntu 24.04 VM, and this will act as the host for our Kasm agent. With the VM up and running, I will SSH into it. Now I'll go ahead and install the Kasm agent role on this VM. Currently, installing Kasm Agents inside Kubernetes isn't supported, so you'll need either a VM or a bare metal system for the agent. If I head over to the Kasm documentation and look at the multi-server installation guide, I can find the commands to install the Kasm agent. There are three values we will need to fill in the installation command. The first is the agent hostname. This can be a public or private IP, as long as it's reachable by the Kubernetes cluster. The second is the manager hostname, which is the hostname where the Kasm control plane is running and accessible. The third is the manager token. Just like the admin password, the manager token can also be retrieved from Rancher using a provided command from the release notes. I'll copy and execute this command to retrieve my manager token. I'll then copy this token and paste it into the install command. Now I'll jump over to my VM and paste the installation commands. I'll accept the license agreement and the agent installation will begin. This may take a few minutes. While that's installing, it's worth mentioning a few additional features. Kasm also supports autoscaling for agents as well as servers. Instead of keeping agents running all the time, you can configure pools to automatically scale agents up or down based on real-time user demand, or even based on time schedules. Autoscaling supports multiple providers, including major cloud platforms and also on-prem environments like Harvester. Alright, the agent installation is now complete. If I refresh the Kasm admin UI, you can now see that the new agent has appeared. I'll enable it, and now it's ready to accommodate sessions. For this demo, I'll install the Ubuntu Jammy workspace from the official Kasm registry. Initially, you may see a warning indicating that the agent is still downloading the image. This is normal and can take a few minutes for the workspace to be downloaded. Once the image download is complete, the warning disappears, and we can now launch the session. And as you can see, we now have a fully working Ubuntu Jammy desktop session running inside Kasm. We can launch applications like Sublime Text, use the browser, and access any of the tools that come with the workspace, or even install new tools as necessary. In this walkthrough, we manually connected a Windows VM and also manually installed a Kasm agent on a Linux VM. But in a production environment, you don't have to manage these resources by hand. Kasm supports autoscaling for both Windows servers as well as Docker agents. This allows Kasm to automatically provision and deprovision resources based on real-time user demand. Autoscaling is supported across multiple cloud providers as well as on-prem hypervisors including Harvester. This means Kasm can dynamically create Windows VMs or agent hosts on Harvester, register them automatically, and also tear them down when the demand drops. I'm not going to cover autoscaling setup in this video since we already have dedicated videos and documentation for each provider that cover the process in detail. You can find links to these resources in the description below. And that brings us to the end of this demo. Thank you for watching. You can find links to the official Kasm Helm chart GitHub repo as well as the relevant documentation in the description below.